Hi everyone, my name is Abhishek Jan, and in today's video we're gonna see how we can securely hash our password, right? So what I have done is I just tried to figure it out what are libraries in Python programming language which supports securing a password dedicatedly, right? And I just came across with bcrypt, argon2, and there are many more, but these two seems to be the more promising one and more acceptable, across the industry, right? So let's see that, why do we need to secure a password by using a library bcrypt and the argon2, right? Okay. So what is bcrypt library, right? Bcrypt library is nothing but which has, a hashing algorithm, which is designed in a way which can slow down the processes of hashing and making more computationally expensive. Why do they need to do this, right? So that they can resist towards the hacker attacks like brute force and the rainbow table attacks, right? So that's the reason they have intentionally designed these algorithms to make it more slow and more computational expensive. And they have given a one parameter, and we're gonna see that, and that parameter actually known as an adaptive work factor, right? That is the last point in this screen, right? So we're gonna see that in a action, right? When we just get into the demo part, right? So what this bcrypt library does is never save your password, in a readable format. It always, save the data into the hash form, right? The other thing is which make it, this bcrypt library more intelligent and more stronger to use a salt. Yeah, salt is nothing but it's just an additional random, the characters, which actually get added to any password before it actually gets, creates a hash out of, right? And that makes every password unique, even if two users are using a same password, but due to this salt, it's always going to be unique, right? That we're going to see. The next one is the adaptive work factor. As I mentioned that this bcrypt library is intentionally designed to be slow and computationally so expensive because we know that as we are progressing, our hardware are getting stronger and stronger, right? To address that issue where your computer is very fast to do this brute force attack and rainbow table attack and other kinds of attack, you know we have an adaptive work factor through which we can just make it more slower and we can make it more computational expansive, even though if you have a very strong hardware based computer that is still doing a brute force attack, and the rainbow kind of attacks becomes very difficult and very hard, right? So that's pretty much it which I wanted to cover from a theory perspective. Let's get into the demo part and see how we can use this. Okay, so I'm using a PyCharm and I have already created a one project known as password secure tutorial. So what I'm gonna do is I'm just gonna create a file name, let's say secure password for apps, right? So this is what we're gonna do. And before that, we have to just install it as usual. If you are from a Python background, then we have to install every library, and I'm using a pip install bcrypt. And you can also, search for the documentation if you want more detail about the bcrypt. And then, as usual, we have to import bcrypt. Okay, and then in bcrypt, we have a function called hash password. If you just see the signature, on my screen, that requires password and a salt, right? So what I'm gonna do is I'm just gonna use one password. Let's say secure my password. This is the password which I'm gonna give, and then I have to provide a salt, right? So to get a salt, what we can do is we can create another variable, a random salt, and then we can use a bcrypt library, and it has a gen salt function which has a round and prefix, which we're gonna see. Right now I'm not giving anything. Let's see, what's the what it gives us when we use it from default settings for rounds and prefix. And then I have to give random salt variable, right? And let's print this out and see what happens. Okay, so these are the 3 lines of code, and we should be able to just hash our password in a unique way, which is more resistant towards the brute force attack and a rainfall table attacks. And okay, string must be encoded. Okay, so it's require encoded. Right now it cannot understand this string, so we have to encode it. And I'm gonna encode this with UTF-8, which is nothing but it's gonna give us a byte data, right? Okay, so now you guys can see this is the value which we are getting, right? So what happens if I just rerun this? Let's see, because we are just again hashing a same password, same plain text password. Let me just run this 2 times. Now we got this, and let me just run the again. So it means that we are just creating a hash for the same password, but every time I'm getting a different hash. And why this is happening? This is happening because of bcrypt is using this random salt, and if you want, you can print this random salt to see what exactly it contains, right? So let's run this multiple times. See, every time the salt value is different, and that actually contribute to make the hash of a same password unique every time you're gonna run. And that way, if you have a multiple user using the same password, here their hash value is always gonna be different. So what happens is, even if someone gets into the one user password, he won't be able to get for the other, because even though the password is same, but the hash is different, right? That's a beauty, right? And that's one thing, right? The I think we can just try to compare with another hash library, hashlib compare with bcrypt. I'm just gonna create this, and I'm just gonna create a hashlib. This is the Python library, and this comes with a Python package, so you don't have to install it explicitly. And then what we're gonna do is we're gonna take the same password with encoding, and I'm just gonna use hashlib.md5, and I'm just gonna give slash c md5 string and used for security. Okay, so we just need security password. Let's don't use encode, and let's see what happens. And let's print this. I know we have to do some. I have to get the hex. Just let's see what happens. So again, we have to encode it the way we had done for. We already have that. So we save it and run this. And the file will pass. Line number 4. Oh. Okay. This here. Okay. So to get the precise value which we can compare, I have to call this hex digest. That would give us the value. So this is the value which we are getting for our hash. And let's see if I run this for the second time, what happens. See, we are getting same. So what does it mean? If multiple users are using a same password, which is quite obvious to happen in a real time, then if one user password gets leaked and other user are also using the same password, it means that your system is going to be compromised for the multiple users who are using actually a same password, right? So that is where bcrypt is very, very strong, right? So that's the reason you should avoid using md5 in hashlib. You can, similarly sha1, sha256, sha512, those also creates the same kind of so we can use 512 in place of md5, and let's see what happens. See, same hash, right? So whatever SHA you uses, if your multiple user are having a same password, it's gonna land up in a same hash value. And if your one user password get compromised, there is a possibility that other user will also get compromised, right? So to avoid that, you should always be using a bcrypt or argon2 or some other library which is provided by in your programming language, right? I'm just talking about the Python, right? So this is the difference of using a dedicated library to secure the password in your application, right? That's pretty much it. And then just move to the next concept, which is adaptive work factor, which actually help us to just slow down the processing of our hash library. Let's see how we can use it. But before that, import time. I'm just gonna import a time because I just wanted to see, how long it takes. So start underscore time. I'm gonna use time start, and then end time, and then I can print and time. We can make it so time to create hash for password. Right. Okay, let's run this and see. Let me just clear this up. Oh, sorry. Okay. So time taken is for this 0.3.384. So if I just go here, gen salt one more time, and then we can see it takes two parameter. One is rounds, another one is prefix, right? So rounds equals to, I'm just gonna give, let's assume 12, because I know if you just read through the documentation, 12 is the one which is actually a default, so it's still 0.3 milli, 0.3, 0.3, but if I just change this to 13, let's see what happens. Now it's getting 0.6. It's almost double, right? You just increase your rounds by one. It means that you are just making your hashing more slower, right? So what exactly happens? What does this round does? Round does means, it's going to iterate through your hashing by 2 to the power 30, right? So if I just run for 14, let's see what happens. See, it's just taking a bit longer. First it was taking 0.3, then it's just double 0.26, and now it's 2.6. If you just compare with the default value 0.3, then it's almost 9 times slower than what it's used to be with the default value. And I know the default value is for rounds is 12, right? So that is how, bcrypt library is very strong and very important for you to use. So if even in the future, if your hardware power gets increased, and your system is, or your application is more vulnerable towards brute force attack or rainfall table attacks, rainbow table attacks, and other kind of attacks, then you can change your rounds, recreate your hash for all the passwords, and then you can good to go, right? So these are some important points. And apart from that, because in real time, if you are using this in an application, then you have to know, I mean, if someone is giving you the password, then how you can verify whether that password is a legitimate to the system or not, right? So in that situation, there is verify. There is a function called check password, which actually takes, if you just see the signature, it takes 2 parameter password and a hash password. So what I'm gonna do, password is, again, this value, and my hash password. So what we can do is we can save this. We can say hash underscore password, and we can remove this, and then we can feed in this. And let's make this here. Doesn't make sense, but anyways, just correct this as well. Okay, so check password, hash value. Okay, so what we can do, password. So this is my variable, right? And then we can say if is true, print user is authenticated success. application, and then we can simply fail to authenticate. Application, reach out to credentials. Okay, so this is pretty much it. Let's run it and see. Let's clear this up. Oh, user is authenticated to allow access to the application. What does it mean? It means that it is actually, giving us a correct password, right? Let's see that. I mean, we are hashing this one, but if we have one here, so this time it should fail. So let's see. Again, I should have changed that wrong. User has failed to authenticate to allowing the access application. So reach out to the admin to get it. So I think this is how you can do this, right? The additional thing which you have to do in your application is you would like to store your hash was, because right now I'm just creating a hash, and then verifying it in the same code. But in real time, what you have to do, you have to first create a hash. When you are giving, when your user is signing up for the first time, you have to create a hash and you have to store in some database, right? Whatever the database your application is using and what is recommended in your infrastructure, right? So you have to store there. And whenever any user wants to log into your application, you have to take that up and you have to use the check password function of bcrypt and just verify from your database entry whether this is a legitimate user or not. And based on that, you can just do it. So I think that's pretty much it, which I just wanted to cover for this bcrypt library. I hope this would clarify why do you need to just secure your password with bcrypt kind of library, so that it is more resistance toward brute force attack and the rainbow table attack. So if you have any questions and if you need more info, like how you want to use this library in a real-time use case, feel free to just put that into the comment section, and I would try my best to just help you on that. So that's pretty much it. As always, thanks for watching this, and stay healthy and keep learning a new thing.